So I think to open this up a little bit, I'd like to start with Dan Steer. So one of the goals of this conference today is to really help us align our sort of our North Star in terms of where the research needs to be going. So what are the hard open problems, and essentially what are the limits of the technology that we have right now that that can be addressed on the 5 to 15 year time scale. So Dan Steer, I thought I'd like to start with you, and the platform you have right now is incredibly impressive, and there were some questions I'm sure you could answer about, is this video sped up, is this real time, and what are your pick rates and success rates? And I'll leave that to you if you want some details on that. But so you really have broken new ground in the field of autonomous high-speed fruit harvesting, and every part of that is hard in the field: autonomy, high speed. But what do you see as the frontier in autonomy, the next frontier? Are there opportunities that our partners here in academia can be working on now that could have a big impact on how harvesting is done?
Yeah, well, so I guess the first thing I'd say is I think we're pushing the limits of everything kind of in each area for what's possible today. So, for example, the perception systems that we're using, we can recognize more than 95% of the fruit in a canopy. We can decide if it's ripe with equal precision to people, with better consistency, because we don't vary by time of day or kind of how long somebody's been working, et cetera. With that said, that's still a small fraction of what a human can perceive about a canopy. And so there's been huge improvements in the last decade in the capabilities of computer vision, for example, and every improvement that will come over the next decade will be one that we'll instantly snap up and make use of in an orchard. And so the first thing I'd say is if you take sort of what the frontier sort of capabilities of robotics, we're pushing the edges on every one of them. Now, what's interesting, when you go from as you're creating a startup, there's sort of two phases we've gone through, and we're still working through the second of those. The first one was, can we invent the solutions to be able to do the task? Can we create a prototype that can do what I described before? Drive through an orchard autonomously, recognize fruit, pick it without damaging it, and without damaging the tree, because that's an important part of permanent crops. And we were very happy with the results we've seen in prototyping. We're at the point now where it isn't so much about having to invent a new capability, but to take a prototype that is basically grounds up automation and turn it into a product, which requires not only thinking about reliability, will the product do kind of repeatedly what you've designed it to do, and will it do the task well, but also will it be durable and stand up to years of use in the kind of very demanding environment. And so the first thing for us is we're still on a path to finish the commercialization of just what we're capable of right now. We think we have everything in place in order to solve the problem of fruit harvest, and productizing it is no small task. Now, the second piece to your question, Alex, about sort of where are the future opportunities. A lot of what we're all trying to do is sort of pick out the places where there's a research solution, where a research solution exists, and now kind of apply it to pick problems that are promising and apply it to them. There are plenty of other examples. If you look in agriculture, there's really sort of there's a part of the world that was automated over the 20th century. My family were cotton and soybean farmers. My grandfather started farming cotton in the 1920s, and the stories he would tell me about when he started were, he and my grandmother had all kinds of stories about picking cotton by hand, and what an awful job it was, how it tore your fingers up. It was grueling work. And, over his lifetime, that became completely automated. You went from literally plowing behind the mule, which is what he started with, and picking cotton by hand, to tractors and combines, and a radically more efficient production process. Specialty crops, which is what you see all of us working on. So things like orchards and fruits and vegetables, which ironically are some of the healthiest food for you, are also still heavily reliant on manual labor, and that labor's been drying up for decades. And there are the tasks that we've chosen. So harvest, in the case of orchards, harvest is the most important problem. It's the biggest labor consumption, kind of the biggest consumer of labor. It's also the part that's most at risk from changes in the labor force, which again they're not new. They're not. It's not necessarily related to the current kind of environment of pandemic. This is the labor force for migrant agricultural labor has been shrinking for decades. So these are areas where harvest is an important problem. We think we've got the tools to solve harvest, but as soon as you give us the ability to have better autonomy, then there are other steps in the orchard that will automate. And and I'll give you an example of one that we're not solving today. That is a research topic, which I think is not that far away, but would be kind of another value add. As we're picking fruit, that fruit gets deposited into large bins, and in the case of apples, those bins are about 4 feet, 1.25 meters square, and about 30 inches tall, about 2/3 of a meter tall, and they hold about 900 pounds worth of apples. And so these are sort of big, heavy things that you move around. And growers will literally harvest, thousands to hundreds of thousands of bins of fruit in a harvest season across a 90-day window. And all of that gets transported out. And so when harvest is happening, there's actually a major logistics operation around moving bins in and out of orchard rows and getting them onto semis, and the semis getting them to storage and sorting facilities. Today, people do that by driving tractors, and it's a pretty skillful tractor driver. It's a bit like if you've been in warehouses, watching people drive forklifts in pick and pack warehouses. They're flying around the orchards. It's pretty cool to watch people that are skilled at that kind of work. If we had an autonomous tug that could navigate not only orchard rows, but an entire farm environment, and all the vagaries that go on with obstacles like semis and people and ruts and mud puddles and dirt and all the rest, that could come in and automate the process of moving bins around. That's another application that would be pretty useful to the orchards that we work in. I don't think today's autonomy is quite up to the rigors of that task. I don't think it's very far away, but it's an example where there's a perception capability that's not very far away that's going to lead to another product that'll improve this supply chain.
Thanks. That's really helpful. And from our conversation before, I thought I'd mention one of my favorite points is that level 5 autonomy in the out in the wild is very, very difficult, in part because you just don't know what people are going to do. But on the farm, it's a slightly more controlled environment in the sense that people are used to being around very dangerous equipment. They grow up in that environment. Yeah. and I think that could actually be very helpful for level 5 autonomy on the farm. Thanks a lot. So my next question is for Eric Adamson. And Eric, I have kind of two questions for you, but I thought just to try and keep with this theme of realism, and coming from academia myself, I'm very aware that as a grad student, your goal in robotics is to produce a good video of something that happened maybe once. And in order to get past that, at the other far extreme is to actually have a product with reliability and whatnot. So I was wondering though, if you could paint a picture without naming names of some of the kinds of demos that you might actually see that are not actually that don't really actually have merit in the real world applications, for one reason or another. Maybe help us understand some of those realities that we come up against.
Yeah, I think this is a very important area, particularly in agriculture, because when a farmer watches a video, they're going to see the problem right away. You really can't slip one by them. So, I think there's sort of a range of robotics companies in agriculture, or just ag tech companies in general, who start with the tech first. Maybe they have something really cool, or they've been able to build something and they got it to work in a lab environment, or even on a test farm where they had to prune away a bunch of the problems so that they have a nice, simple, easy, repeatable setup. And if you have that kind of video or you have that kind of demo, it's of course impressive. I mean, all the work that everyone on this panel is doing is really impressive, but the farmer is going to ask the next question right away. Well, what's it going to do when this thing happens, when that thing happens? In strawberry, for example, depending on the grow conditions, depending on the temperature at night and how sunny it is, you might have a strawberry that is completely ripe on one side and completely unripe on the other side. How do you address that problem? And these are the things that the grower is going to ask right away. So, there are many videos out there, particularly for us in strawberry. There's a number of videos on YouTube or on the internet about, a robot picking strawberries. And the first question you ask is it picking the right berries? Is it picking the strawberries in a farm that is actually an operating farm? Or is this a completely controlled environment that is not scalable because you had to put a lot of money in the form of labor to make it look that nice? So as a company, our approach has been the opposite. It's basically throw the thing into the wildest, scariest environment and stand there and watch it with the grower. And it's embarrassing, on occasion you make a mistake or you cut off an entire, bunch of fruit that you shouldn't have cut, but that's how you learn. And by doing that and bringing the farmer along, we've learned more, and we also gain their trust because they know we're not trying to pull over their eyes. We're trying to solve the real problem. So I think that's critical for any company in this space, is to actually solve the real problem and not be afraid of the difficulties.
And so working with real farmers in the field day in and day out, getting sweaty.
Absolutely. Getting muddy, wet, sweaty. Yep. All of the bad things.
That's another theme I've heard from pretty much everybody in the ag tech startup space, is that, agriculture is a dirty, rugged, muddy business with lots and lots of physical challenges like that. Great. So this next question was sparked by my discussion with Eric, but it's really for anybody on the panel. So there's been, certainly at the consumer level especially, there's been a movement to support small farm operations as opposed to large corporate agribusiness models. With these different technologies, some of them may support small farms, perhaps even the sort of robotics as a service business model may support small farms. In the case of your particular technologies here, do you see that as being the case? And also, but the real question is, is that a noble goal, and what is the high level value that we should be seeking as an industry?
Well, was that for Eric or?
That is for whoever wants to speak first.
All right. Well, I've got some thoughts on that. So the first piece is, I think most of us are bringing these agricultural robotics to market as a service. And the first thing to point out is that's not new. There's a business model in agriculture that's been around as long as there's been, combines called custom harvest, which is simply that, a company will own harvesters and they harvest as a service. And, if you're from the Bay Area, it's really common to see that business model, for example, in the wine industry. And you don't just see it in the field, but you also see it in things like, the machines that crush grapes for small and medium-sized wineries. So, the first piece is certainly the business model that we're coming to market with, as a service, as a custom harvest business, is very familiar to large and small growers, and certainly makes what we're doing accessible to all of them. I think about what we're doing in terms of what I mentioned before, which is sort of my grandfather's experience across his lifetime. He was born into a family that owned kind of a small, medium-sized family farm in northeastern Louisiana. When he started farming, he literally walked behind a mule with a plow, and experienced an evolution in farming through the introduction of just a series of types of automation that made farming radically more productive. And that meant there were fewer people involved in farming, but those people, I don't think they're any of the grandchildren of the people that were farmhands or that were in my grandfather's family that decided not to farm as the farming became more productive, that would want to go back and pick cotton by hand the way they used to. And so I think our mission is to increase the productivity of food production so that the people that are involved in food production have a higher standard of living, and so that, you know, society in general is better off. I mean, that's what fundamentally, that's what automation does, is improve productivity growth. And so, you know, I think that's what we're all working toward. And the interesting thing in agriculture is, if you're not familiar with it, there's a really big difference in the productivity of farming operations that are amenable to automation. So, you know, row crops, you know, imagine if we were still picking cotton by hand for, you know, what it would be like to clothe 7 billion people in the world. And specialty crops. So fruits and vegetables are much, much more reliant on migrant manual labor, and that's not going to continue to scale. So, you know, we're in some ways trying to head off a crisis in the global industry.
Thanks. Great. Eric, did you want to add anything to that really quick?
Yeah, I mean, I think what I like about what Dan said is sort of putting what is the point of a farm? What is the point of the industry that we're working in? It's not to have small farms, it's to have food on the table. And I think my vision and sort of Tortuga's vision for a future system isn't necessarily, you know, massive scale farms or helping with only the small farmer. It's something in the middle where you have a more distributed food system where we can feed more people in the world with high value, high nutrition fruits and vegetables and other things that people love to eat. But you don't have to do it from, you know, only one region, you know, shipping fruit all over the world or shipping vegetables all over the world. So it's more of a distributed food system, which is where sort of the controlled environment aspect of this comes in. And it doesn't have to be a vertical farm. You can just have a light shade cloth over the top of a tomato farm or a strawberry farm or whatever. But those farms don't necessarily end up being very small farms. They actually are scale commercial businesses. They may be owned by a family, they may be a corporation. But what's good is that it's a better quality crop for the local environment around that farm or that complex of farms. And where you see this model kind of already exists is in Europe, where, you know, every country kind of has a lot of their own supply for crop, fruit and vegetable in particular. There is some exporting and importing happening, but there's a lot of local production as well, and people like the food that they eat that's local. But they're big businesses. They're efficient businesses. They're more productive businesses from Dan's point of view. So I think that's the important thing is, like, I think there's an over-romanticization of small farms and putting your hands in the dirt. Farming is just hard work, no matter where you are, no matter what you're growing. And I think robotics might help certain farms get bigger, and I think that's okay.
Mm-hmm. Thanks.
You know, and also to add to that, I think that both Eric and Dan and my own FarmWise's own product is agnostic to whether it's operating on a big or a small farm. If you meet certain constraints, we can send our service out to you. End of story. Now, whether or not that makes sense fiscally is another question, right? And then also, does it solve the kinds of problems that the small farmer is trying to address is another question, because I think the constraints on a small farmer are probably quite different from that of a commercial grower.
Mm-hmm. Thanks.
A bit from Swan Farm perspective, I guess we see ag robotics as very much, you know, leveling the playing field. Like, if you look at countries that are developing nations that ag tech's left behind, they don't have John Deere dealerships, they don't have Case IH dealerships. Their farming systems have evolved without ag technology and modern ag equipment. And so their farming systems are based around that. A lot of them are subsistence agriculture, some of them are commercial. But they produce huge amounts of food and feed, you know, millions of people around the world. And, you know, we see that some of these nations are kind of going to skip the copper wire and go straight to connectivity. In that we've seen that in terms of mobile connectivity and communications in these countries. They never had copper wire and telephones, they went straight to mobile technology. And I think that some of these nations are going to leapfrog, you know, developed nations in terms of adoption of robotics and ag tech. And because they don't have that legacy, they'll be quicker and faster to accept new business models, new delivery models. And they may not have the same robot that you see in a developed nation or a, you know, very advanced farming system. It's going to be a different robot, but they've got problems they need to solve too, and they're very valuable problems, not only monetary, but also in terms of, you know, food security and also environmental impact. And I think some of the solutions that ag robotics are going to deliver to them are going to be quite breathtaking as well.
Great. Thank you very much. So this last topic, I believe we have about 10 minutes left if I'm following the schedule correctly. So there's been and this is for everybody on our panel. So there's been a lot of talk about data-driven farming decisions. It's actually relatively easy to make a pretty two-dimensional heat map of various parameters on a field. But I think there are a lot of challenges in finding actionable data, data that can actually be used by the farmer or by the robot. Now here we have in this group a couple of cases where the actionable data is immediate, like pick this apple, don't pick this apple, or remove that plant or not, depending on if it's a weed. But I was wondering if our panel could help the audience see a little further into the future. What are the challenges around longer term actionable data, and what kind of actions would we like to be taking right now that we're not able to take, maybe because we can't?
I'd love to take a stab at that if my other panelists are okay with
Please.
begin. I think we're all eager to tackle this one. This is a great question. So FarmWise is out there during the early stages of the growth cycle. And so in terms of actionable items, one thing that we're really excited about is optimizing yield, right? It's about how can we help the farmer make more intelligent decisions so that they're actually doing more with less work, or they're producing more food on the same field. That's really the long-term vision, and that's really where we'd like to be. I think in the Q&A, somebody was also asking about plant level decisions. And that's another really exciting area. That's all about distributing the right amount of fertilizer at the right point in time for a particular crop. And so this is less about generating heat maps. It's about tracking the individual growth of individual crops. And it is extremely difficult not to make that decision, but to get the data so that you can make that decision. And that's something that we're hoping to tackle in part by being out there during meeting, going out there multiple times. But even that might not be enough. And so it might be some time before we're able to make really, really intelligent decisions on farms, but that's something that I think a lot of us are working towards.
Thanks. Anyone else?
So it was interesting. There was I just saw a comment come by of somebody saying, as a farmer, I don't want AI making decisions about my fields. and I have to say, as somebody who bangs my head against a post most days, struggling with AI, I understand that. But just let me give a different flavor to that, because it's not about AI replacing human judgment. AI, quote, AI today is nowhere near human judgment. There isn't general purpose AI. And I think it actually does the industry quite a large disservice by the way that it gets sort of hyped sometimes. But what we can do, and this is an interesting thing about robotics, is collect an immense amount of data while we're doing the physical tasks that we go about and do. So for example, just to harvest, through the act of harvesting an orchard means we collect more information on the production characteristics of that orchard than pretty much anybody's ever been able to capture, because I can tell you the 3D location, size, and ripeness of every piece of fruit on every single tree in that orchard. And that's not information that growers have been able to utilize before. So I can't tell you today exactly how that information will be put to best use. But I can tell you that most growers that we've been working with for several years now, look at that and think that there's going to be something interesting that will come out of that. And this is another one of the areas where for the research community that's participating here, if you assume you have large amounts of sensor data around crops, there's still a lot of research work to be done to best apply that data. And the thing I can tell you is, with these kinds of machines operating in all of these different agricultural environments, there's going to be a lot more data available for researchers to act upon. And yeah, part of our business will be figuring out how to best deliver and apply the data that's collected through the work that we do.
I think just to add, our perspective, we have a unique crop, maybe even amongst the group. You know, a strawberry plant or a lot of fruiting crops will sort of continue to fruit over the course of up to 6 months. So our farmers actually, you know, our customers they're in the glass house from March. They're in the fields from April. The fields go until November, sometimes December, and the glass house is happening again. So you're harvesting for 10 months of the year. Pretty amazing. Even in climates you wouldn't expect to be able to do that. And so in those environments, it's actually closer to being a reality already because the information that they already want to know, we can give parts of that information to them now. And it's not just about increasing productivity in the sense of yield by having more information and making better agronomic decisions. It's also really interesting outcomes like, well, if I just have a photo of every berry that you picked today, that's defensibility against my customer who's a supermarket who's constantly busting my chops for my quality and like kicking back massive orders, and I waste tens of thousands of dollars. You know, having information about plant level yields or even just meter by meter yields in a farm can be ammunition against your supplier, where you can say, hey, look, the quality of the rootstock you gave me this season was poor. And I know that because look at the data that I have. You can also use a lot of the data already for contracting purposes. So, you know, better forecasting 2 to 4 weeks out means a better volume estimate means avoided penalties if you don't hit the volume, or you know that you're going to have too much, and so you can go find a home for that on the spot market earlier as opposed to having to waste fruit. So like the information can truly help in terms of the agronomic decisions you're making, and that is kind of the holy grail that a lot of the other folks have already talked about. Like, how do we actually know what to do with each plant? But even before that, there's business side decisions and business side information that can be used pretty quickly in certain crops. It's not applicable to every crop, but.
Those are great examples, and that's something that I think speaks to the larger point of risk management. And for a lot of farmers at this point, so early on in the technology life cycle, trying new robotic technologies is risky. But if you can turn that on its head and provide new ways to manage their risk, then it's actually a real value add.
I think, I guess sometimes we kind of overestimate the impact of technology in the short term, but kind of totally miss the boat in the medium to long term. I think robotics gives us a chance to actually go through years and years of old research that's been shelved because it didn't work on the back of a tractor or it didn't fit in the agronomic system that we're currently growing with now, and go back through it and see, you know, what else is out there that we can actually apply to agriculture, because it's not just the technology, it's the agronomy to go with that technology. And example of that, I think, is even plant breeding. Like every year I go to our hybrid seed variety trials for sorghum breeding, and I've got all these different lines of genetics and plants that they've bred to see, you know, which ones are going to be the new hybrids they release the next year. And we have a bet. There's a thing where it's competition. You guess which variety is going to yield the highest, and we all have a few beers and walk down the rows as farmers, and there'll be some beautiful variety there that it's outstanding, looks better than everything else. It'll win the variety trial that year. And then the next year in Australia, we have a lot of drought and variable weather. The next year, that same variety will crash and fall over because it's too dry a year, and will get thrown out of the plant breeding program because it can't perform in a good year. And there was a researcher at one of these variety trials that I go to every year, and he had this work where he was cutting leaves off plants, and he said, you know, if we cut leaves off with scissors, we can change the plant water use efficiency, and we can make some of these varieties yield higher in a drought year. And I remember this is, you know, 20 years ago, and I was kind of, you know, straight out of university, and someone saying, oh, what a load of crap, we'll never do that. That's just not practical. And that research got thrown out. But it wasn't just that research that gets thrown out. It's the agronomy and the plant breeding that our plant breeders are throwing out every year because they're only breeding for the technology we have now. The real opportunity with robotics is when we can bring new farming systems, new plant technologies, new things we can apply in the field. We can actually unlock genetics that we're throwing out right now and putting no value on, because that variety that gets thrown out every year that can't handle a drought year could be the next variety that lifts sorghum yields by 10%. And we're not getting gains like that in agriculture now. So by going back through research, we can start finding things that can unlock agronomy that we've already discovered, but we threw out as unpractical. So I guess, you know, this thing about robotics is about solving problems at a micro level not a macro level, which is what we're seeing in modern agriculture.
Thank you very much. So we're out of time, and I think it's a good sign of a really wonderful panel that we had many questions that we weren't able to get to. So apologies to the audience for that, but the chat log will live on, and there may be opportunities to come to some of those in the future. But I really want to thank our panelists for a wonderful discussion this morning, a great way to start us off right. Thanks, Anil.